Hello. In this video, we're going to take a look at solving equations and inequalities with absolute values. So start out easy. We have the absolute value of x equals 5. What number could I put in for x to make this equation true? You're probably thinking 5, right? Plug 5 in there, the absolute value of 5 is 5. Are there any other solutions? What about x equals negative 5? The absolute value of negative 5 is positive 5. So this simple equation has two answers, x equals 5 and x equals negative 5. A shortcut for writing this is plus or minus 5. So you may take that and look at number 7 and be like, oh, the answer is just plus or minus 10.7. And you would be wrong. Okay? If you take a look, if I put positive 10.7 in here, the absolute value of positive 10.7 is positive 10.7. In fact, if you stop a minute and you look at the original problem, you see this says, what positive number equals negative 10.7? There are none. So for this one, we just write no solution. And this is a good idea when you're solving absolute value equations to pause and think about it and say, what is this even feasible? So let's take a look at some that are slightly more complex. Here we go. I'm going to leave example 2 for you, and let's do number 32 together. So I'm taking here 5 minus some number equaling 2. I think that's feasible, right? That makes sense. I can do that. So, in fact, this some number has to be 3, doesn't it? And we'll get there actually in a different way. But I'm going to start by just getting the absolute value by itself. Start by subtracting 5 from both sides, and then removing or multiplying both sides by a negative, however you want to look at it. That gives me 4x plus 3 has to equal 3. And at this point, there's two ways this can happen. You need to split these into two problems. 4x plus 3 could equal 3, but 4x plus 3 could also equal negative 3. Do you see that? If 4x plus 3 is negative 3, then the absolute value of negative 3 is positive 3. So we just solve here. 4x equals 0, divide by 4, x equals 0. Or subtract 3 from both sides, we get negative 6. Divide by 4, we get negative 6/4, or negative 3/2. So this equation has two solutions here. X equals 0, and if you plug it in, you'll see that that works. 4 times 0 is 0, plus 3 is 3, 5 minus 3 is 2. Plug in negative 3/2 here. We get negative 3/2 times 4. It's going to give me negative 6 plus 3 is negative 3. The absolute value of negative 3 is positive 3. 5 minus 3 is 2. Sorry, that's a lot of work. All right, let's look at inequalities. What if I have the absolute value of x is less than 5? You might be thinking, well, that's easy. Just 5. This is an open circle since it's not equal to, it's just less than. And I go like that. And you'd be sort of correct. You'd be correct as long as you pick numbers like 4, 3, 2, so on. But what if we pick a number way out here like negative 10? The absolute value of negative 10 is positive 10, right? And positive 10 is not less than 5. So this gets into the issues at hand. All right. The key is, as long as it's between negative 5 and positive 5, it'll work. Try it out. Put in negative 4. That's true. Try something outside like negative 6. That's not true. Okay? All right. The only difference between this one and the last one is the equal to symbol. Hopefully you're comfortable with that. What's the difference? The difference is these circles just need to be filled in, because now it can be equal to. How about when its absolute value of x is greater than 5? using the same ideas and thinking about it, makes sense all of these are true. But what about the negative side of things? Just like we did earlier when we picked negative 10, that was a solution. Or it will be here. So when this situation, and I'm going to encourage you just to think through these examples and not necessarily just memorize a bunch. So over here we have the similar problem, but now it's equal to, so we just fill in the circles to show that it can equal 5 and negative 5. Alright, so let's take a look at example 5. Example 5 we're going to set up, and we're going to think about this in two ways. We need 5 minus 2x to be greater than or equal to 1. So kind of thinking about this, if this was 1, we would want things out here. So 5 minus 2x has to be greater than or equal to 1. But remember that whole idea of it could be out here as well? So we're going to have to split this problem into two parts. 5 minus 2x could be less than or equal to negative 1. Now, I'm going to erase this. This isn't the solution. That's just to help us figure out the two parts. The solution now, we just treat these separate. We subtract 5 from both sides, and we get negative 4. Divide by negative 2. Remember when we do that, we've got to switch the direction, the inequality. So x is less than or equal to 2. Over here, let's do the same. We subtract 5 from both sides, negative 6. Divide both sides by negative 2. Again, notice the sign switches directions when we divide by a negative. So now we get our final solution. X is less than or equal to 2, and x is greater than or equal to 3. So less than or equal to 2. And x is greater than or equal to 3. If I was going to write this in interval notation, we would write negative infinity, comma, 2 with a square bracket, the union symbol, 3, comma, positive infinity. Either one of those would be fine. Okay, I'm going to leave example 6 for you to do on your own, and let's look at number 64. Before you jump and start thinking, oh, okay, where is this going to be greater than negative 1/2, and then start thinking about the positive side, just stop and look at it. This says that some positive number needs to be greater than or equal to negative 1/2. But if you think about it, you see this is always going to be true. This will always be greater than negative 1/2. Even if we get a number like negative 1,000,000 in here, the absolute value is going to make it positive 1,000,000, which is greater than negative 1/2. If we pick just the right number, we can make this 0, but 0 is still greater than negative 1/2. So in this case, all numbers are solutions. You could also just write all real numbers if you prefer. Something's kind of weird here. All real numbers. Alright, so I'm going to encourage you to go back and solve example 2 and example 6. Go ahead and pause the video. And here are the solutions. Example 2, example 6. You can see we followed similar patterns. Thanks.